the lateral hub stress, which this is the hub right here, okay, is going to be reduced by a bunch of different effects. First of all, we have flexibility in a bunch of different areas. The materials that the prop wings are made out of are flexible. We have flexible bamboo, flexible mylar, flexible polycarbon hex towers, flexible outer hex ring, and all kinds of materials. Now all these flexible materials is going to help absorb the lateral hub stress, okay, from one side to the other as the prop wing is accelerating around and around. And what happens is, as the prop wing is doing this, is a prop wing, the acceleration and the deacceleration, which is taking place simultaneously at the same time, wants to create a real angular movement. In other words, it on a right angle away from the hub, it wants to create this movement. It wants to shift the center of mass outward from the inside to the outside. Now it's going to do that in combination with the lift, okay, because we have the lift, which is at the smaller, going from the inside to the outside, but also we have this angular movement created by the actual spinning hubs and the actual wings themselves, which also wants to move from the inside to the outside. So essentially what we have here is we have great lift being transferred to the outside, and when it reaches the outside it stops, and what does it do? It lifts there as well. So we have lift and lift and lift being forced outwards, so you got this constant forcing and constant lifting from one to the other. So we see the rolling force of the prop is also countered by the gyroscope that is built into the craft. Okay, this orange transmission box that you see here is mounted on a gyroscope designed steering box, which essentially is going to prevent the prop from flipping over. Now, just so you understand what we designed into the craft, think of this prop wing as being a bicycle wheel. Now, if the bicycle wheel was this way, take it and turn it this way. Now, what I want you to do is think of the shaft going from this way to this way, so the wheel's this way, the shaft is this way. Now, what you want to do is you want to grab hold of the shaft, just like this. I hope you can see all this so good, okay? And you want to spin the wheel, and while you're grabbing onto the shaft, try to turn it, okay? You go frontwards, it comes back to the center. You go backwards, it comes back to the center. You go left, it comes back to the center. You go right, it comes back to the center. That is what is going to happen with my prop wing. Because of the unique design of taking this whole prop and mounting it on a transmission, and the transmission is mounted on a gyroscope steering box, that as this prop is rotating up to the correct revolutions per minute to lift this thing off the ground, it's not going to just start spinning, 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 and then flip over on its side. It will constantly be self-correcting, self-righting, and the faster and faster it spins, the harder it will be to have this craft flip over. The best thing it will do is just keep on spinning and spinning. So these are some of the things that we have built into the design of this particular prop wing, the 8-wing ducted prop wing for Gyro HPH.